In this video, we are going to talk about rationalization. For this particular example, we want to rationalize the denominator. This means we want to get rid of the radical sign in the denominator. Our answer should not contain a square root of 6 in the denominator. So the way we can do this, because the square root is just a simple square root, we can multiply the square root of 6 by the square root of 6. Because when we multiply these two together, that gives us the square root of 36, which in turn is just 6. And as you can see, there's no more square root sign. But notice, when we multiply the denominator by the square root of 6, we also have to multiply the numerator by square root of 6. This keeps the ratio of our fraction the same, because the square root of 6 over square root of 6 is like multiplying by the number 1. So whatever you do to the bottom, you have to do to the top, and reversed order too. So let's complete the problem. If we multiply 4 times the square root of 6, we can see that our 4 and our 6 in the denominator have a common 2 that we can cross out. Therefore, our answer would be 2 square root of 6 over 3. So for this example, we're going to rationalize the denominator. And if you notice, our denominator contains more than just a simple radical sign. It has the square root of 5 minus 1, which contains 2 terms. So in order to rationalize, what we're going to do is we're going to use and multiply by the conjugate. So if you look over to the right, the conjugate of square root of 5 minus 1 is the square root of 5 plus 1. All you do is you change the sign from positive to negative or negative to positive. And if you remember the FOIL method, this is how you multiply out the square root of 5 minus 1 times the square root of plus 1. It's how you multiply two binomials. Remember, first you multiply the first two terms. You get the square root of 5 times the square root of 5 is the square root of 25. The outer two terms is 1 times the square root of 5. The inner two terms is negative 1 times the square root of 5. And the two last is negative 1 times 1. This simplifies to 5. These give you 0 minus 1. So when we multiply the two together, we get the number 4. So by using the conjugate, plus and minus, the middle terms should subtract out to give you 0, and therefore we have no more square root signs. So let's come over to the left. To rationalize the denominator, we're going to choose the conjugate, which is the square root of 5. And remember, you choose the opposite sign. So since it's minus 1, we're going to use plus 1. And whatever you multiply the bottom of the fraction by, you must multiply the top, otherwise known as the numerator. Remember, this is like multiplying by the number 1, and our ratio of our fraction has not changed. So now I want to multiply out the numerator and the denominator, but I will say this. I may wait to multiply the numerator through, and the reason I say that is a lot of times when you multiply the denominator out to get rid of your radical sign, you are left with a number that crosses out and cancels with something in the numerator. So I would wait to do any kind of multiplication in the numerator. So I'm going to leave it as 8 times the square root of 5 plus 1. And in the denominator, if you remember to the right, we multiplied using the FOIL method, and that gave us the number 4. So this is what I was talking about. We're left with 8 and a 4 in the numerator and denominator, and those can cancel out a common 4. And we are left with 2 times the square root of 5 plus 1. This is fine to write your answer this way. If you wanted to multiply the 2 through, you could and get 2 squared of 5 plus 2 times 1. Either of these answers are okay. And we have successfully rationalized the denominator, because even though there is a square root of 5 left in the answer, it's not in the denominator. The denominator here is an understood 1. So for this example, we want to rationalize the numerator, which is very similar to the example we just worked. So if you look at the numerator, we have the square root of x plus 4. It contains the square root, which we want to get rid of, and it also contains 2 terms. So in order to rationalize, we need to use the conjugate. Okay, and what we can do is we can multiply that numerator by its conjugate, which happens to be the square root of x minus 4. Remember, the conjugate is the exact same term with a different sign. Okay, so we want to multiply those together. But don't forget that whenever you're dealing with fractions, if you multiply the numerator by something, you have to multiply the denominator by the exact same thing. Our goal here is to rewrite this fraction, but we don't want to change it. So by multiplying square root of x minus 4 over square root of x minus 4, that's the same thing as multiplying this fraction by the number 1. And we know that whenever you multiply anything by the number 1, you get that original fraction back. Okay, we have it set up correctly. And now it's time to multiply things out. Now if you remember, sometimes we're going to wait and not multiply everything out with the hopes that we might be left with common factors that could cross out. So since I'm rationalizing the numerator, I'm only going to multiply out the numerator and hope that I'm left with something that may cancel out with something in the denominator. So let's multiply this out. Using the FOIL method, we have the square root of x times the square root of x, which gives you the square root of x squared, but those cancel out, so you just have x. The outer term is negative 4 times the square root of x. The inner term is plus 4 square root of x. And then the 2 last terms are 4 times negative 4, which is negative 16. Okay, so let's copy down the denominator. I'm not going to multiply that out. So the numerator, we are left with the negative 4 square root of x and positive 4. Those give you 0, which it should. So we are left with x minus 16 in the numerator and x minus 16 times the square root of x minus 4 in the denominator. So just what we were hoping. We have a common x minus 16 that can cross out. That leaves us 1 over the square root of x minus 4. So we have successfully rationalized the numerator. Because once again, I asked for the numerator to be rationalized. There is a square root, but it's not located in the top of the fraction. So this is our answer. Let's do another example where we rationalize the numerator. Let's look at 5 minus the square root of x over x minus 25. And we want to rationalize the numerator. So let's first find our conjugate, right? And we know that the process is we can multiply 5 minus the square root of x times 5 plus square root of x, multiplying our conjugates. And whatever we multiply the top by, we have to multiply the bottom. Okay. So multiplying out, I'm only going to multiply out the numerator, and I'm going to leave the denominator for a while with the hopes that there's something that could possibly cancel. So let's multiply out the top. We have 5 times 5 is 25. The 2 outer terms is 5 times the square root of x. The 2 inner is minus 5 times the square root of x. And the 2 last are the square root of x times the square root of x, and that was a minus. That gives you x. Okay, like always, and it should work out this way, the outer and the inner terms should add out to give you 0. So, let me copy this down. 5 plus the square root of x. We are left with 25 minus x in the numerator, and we have x minus 25, 5 plus square root of x. Okay, so we have successfully rationalized the numerator, but we do want to check and make sure to see if something could simplify. So we have, if you notice in the top, we have 25 minus x, and in the the denominator, we have x minus 25. Okay, they're not the exact same thing. They differ by just a positive and a negative. So you can't just cross them out here, but what you can do is you can factor out from the numerator. If I factored out a -1, that would change it to negative 25 plus x. And now, simply by doing that, negative 25 plus x is the same as x minus 25. So these are actually the same thing. So, by factoring out the -1, you rewrote the problem in a way that you could cross out common factors and simplify. So our final answer is -1 over 5 plus square root of x.